Bubbles. Bubbles, okay. Yeah, all right. Okay. Hear anything? Yeah. Well, I think usually we got the tab here. Yeah, we got the hair. Yeah, right.
All right, how about now?
Yeah.
Okay. Okay.
Okay. Shall we start?
All right.
Okay, great. Thank you. All right. Hello, everybody. This is fourth interest group. If you remember way back when the morning session was called fourth modification lab, and then I think fourth modification lab becomes a conference that we had in Selamar for a while. But I think usually the morning session in the old days, it's called the fourth modification lab. And this morning, the topic ESP4 browser is kind of like fourth modification. Okay, we try to fit fourth into the browser universe, and this is some of the experiments that I have done. So I'd like to share with you. So I would talk a little bit about the serial I/O in general, and I just want to mention the ESP8266, the prior version of the ESP32, and in ESP8266, I implement the Wi-Fi using the UDP protocol. But UDP is kind of awkward. So I wanted to go to the more prevalent HTTP protocol. And it all boils down to eval, okay? And this is the eval is the center of forth. So if you get down to eval, you can move forward into various environments. And this is the, I use the browser as the interface for this forth on the ESP32 chip. And in the actual implementation, the forth is implement as a callable subroutine, C callable subroutine, evaluate. Okay, and I would make some comments about how would you go about doing programming for the ESP32 chip. So the serial I/O in E4, I try to simplify everything so that the serial I/O is concentrated or boiled down into two words: key and emit. So key accept one character from the terminal, and emits one character. So this makes the forth extremely simple and very easy to implement. You can move eForth anywhere into any useful microprocessors. And at the time, hyperterminal was my choice of serial interface on the PC. So you just type characters, and the hyperterminal would display whatever is echoed from the target. Of course, if you look back into the more sophisticated forth systems like polyforth and these things, the I/O more complicated because it's the input is accepted by the word expect. So it's expecting 80 characters from a terminal. And when you hit return, it will return whatever characters that was received. And then on the output side is the type. So you can give a string with address and length, and you will type the whole thing out. So this is much more suitable for in an operating system environment where you really don't want to capture characters. If you can capture long lines of code and do that thing much more efficiently. Okay, in the ESP8266, that was about 3 years ago, I used UDP. The reason was that that's the only thing I understood at the time. It's the simplest protocol, and it's the simplest one to call and to send characters and receive characters. But UDP sends and receives packets. So it's like expect and type. And so yeah, in the ESP8266 E4, I use accept to receive characters. And it would receive characters from the serial monitor as well as from the UDP packet. So it runs in parallel simultaneously. If you have packets sent from the terminal, it would put them in the terminal input buffer. If it receives a packet from the UDP interface, it would also put that exactly in the same terminal input buffer, and then Ford would be able to interpret it. So emit is also modified so that in parallel with sending out the characters to the serial terminal, it also buffered the characters in the UDP output buffer. And only when CR, character return, is executed, then the whole assembled UDP packet was sent out in its entirety. This way it worked. So it worked. The serial terminal and UDP worked in parallel. So that at the time, I only have to send out some simple false words to the target machine. So it worked either typeing or using a UDP terminal emulator to send out the UDP characters. But we have to, I had to use a UDP terminal emulator. Just like hyperterminal, it's another thing that you have to have on the PC to be able to handle the UDP output and the UDP input. At the time, I start to appreciate the serial monitor on the Arduino. So Arduino system has the serial monitor, and I didn't like it because it's not quite like the hyperterminal. But then using use it more, I find that the serial terminal is actually quite nice. It doesn't send out characters by character. It doesn't receive things character by character. But if you configured your command into one line of words, then you can send everything all at once. So that becomes quite. Once I get used to it, it becomes quite nice. So I have basically throw away my hyperterminal and work mostly with Arduino serial terminal. And then I wanted to really get rid of the UDP protocol and use HTTP protocol. So actually, there are lots of examples, tutorials about how to use the browsers to control the ESP32. And basically, what this UDP, what it is doing is work like a server. So the client would send a URL, a packet, and then the ESP32 would decode this URL and extract whatever the information it wanted, and then turn the LED on or off, or turn the motor on and off. So and once it has carry out its command, it will send out back a web page. So the web page would display the result, the current state of the robot, and also it would display some buttons, and the user can click the button to send out the next URL. So, and this interface, I think it's a more natural interface for the internet. If we want to do anything on internet, the HTTP interface is much more prevalent and convenient for the user. So I wanted to use the browser to control or talk to the target ESP32 machine. So let's review a little bit the fourth interpreter. So generally, fourth is a self-contained system. It's its own operating system. So from the start, if you power it up or hit the reset button, it first go to code. The code initialize the fourth virtual machine on whatever the environment it is. So once you got the fourth, you have the fourth virtual machine running, and then it falls into abort. And the abort falls into quit. And quit is a loop, a query and eval loop. So you query, you read one line of input, and the eval would interpret that line. And during interpretation or after the interpretation, there is a mechanism to detect whether there's an error. If an error occurred, the force goes back to abort. And if there's no error, it goes back to quit, okay, to get the next line. So this, when I first read fourth, it's kind of bothered me that, you start from the code. Well, that's natural, but then you go to abort. Yeah. To get fourth system alive, and then you quit, but you really start. Okay, so abort and quit is kind of strange. And in Chinese, we want to use a word which has positive meanings, and this abort and quit is very negative. But once you understand how the things are arranged, abort and quit becomes obvious, because actually abort, you can give it another name there, but eventually when there's an error occurred, you have to abort. So you have to use abort another word to handle the error condition. And why don't you just call that that location of board. Okay, so it's a quit. Okay, but the essence of fourth is really in eval. Okay, so all these things, just set up everything until you can evaluate a line of fourth words. And then this query is the user interface. How you get a line of code, that depends on the system, okay? In regular fourth system, we have the UR. So we have the terminal to get input and have terminal, have a screen to display the results. But you know, you change that query, that part, the eval would still work the same. Okay. So in the E4, you can see quit is a loop of query and eval. And query, it just opens up the terminal input buffer and expect up to 80 characters. But here I expand the TIB so that it would accept up to 256 characters. So you can really send big lines of code, big packet. And then the eval. In this implementation, in the E4 implementation, it is again a loop. Token would break up the input line and get the next word. And if the word is a valid word, you go to tick evolve, which has either interpret or compile. So depending upon the state you are in, you either interpret the word or compile the word. So this tick evolve fetch execute is doing that switch. Okay. And when you go around, when you reach the end of line, you get here, and you drop off the address and send out that response.ok. So that's how fourth interpreter is implemented in E4. And the central part is really this eval. So you will process one line of code. All right. We all, usually, when we think about the fourth, it's an interpreter, it's a compiler, and we usually think of the quit loop. But now, you can see if we separate the input-output part from the system, actually eval is the essence of fourth. If you can handle the input and output separately. So if you in other language operating system, we can invoke fourth by calling eval as a subroutine. Okay. What you have to do, in the operating system, what you have to do is to stuff the fourth words into TIB and then call eval. When the eval is done, I think the calling is kind of easy, but returning is difficult because fourth is always in normally in an infinite loop, and you have to break up that loop at the proper time, returning to the operating system. So to integrate eval into other languages and operating systems, we just have to make sure that eval gets all the fourth word in TIB, and also eval can exit fourth and return to the calling routine. Okay, so the in ESP32, Fourth is a virtual machine. It is executing bytecode inside the virtual memory, fourth virtual memory. What the entire machine, the fourth virtual machine is really doing simply this. So it fetches 1 byte from the fourth virtual memory, pointing to byte P. And then it would execute the C code assigned to that bytecode. And then it just go around and fetch the next byte and do the next byte and next byte. So this is the virtual fourth machine. And it's basically in an infinite loop. It just look for bytecode and then just execute the bytecode. So to embed this fourth into other system, you have to break this infinite loop. Okay, so that it can return, not stay in the virtual fourth machine forever. So this is how I configure fourth into a browser in the ESP4 version 5.6. So ESP4 would receive an URL. It would decode the URL for the fourth part of the input stream. Fourth words in URL are handed to eval, to evaluate. And we must have a break condition. A break instruction in ESP4 causes fourth to exit the infinite loop and then send back, once it exits, it can go back to the operating system and sends back a web page. So the URL receiving part and the web page part, there's no way that you can write it in fourth. So, but it's very easy to call in the Arduino C system. And so you just, if you establish this loop instead of the infinite loop in fourth, we got fourth embedded. So the loop, the infinite loop in the fourth system to interface with the browser is that you get a URL, decode the URL, and put the fourth words into the TID, and then call eval. And after eval is done, it will send out a web page. And this web page would contain all the characters that's been generated and accumulated in the eval command. Sounds reasonable? Very reasonable. Okay. Okay, how do you break out the infinite loop in the virtual fourth engine? When I implemented the bytecode, bytecode 0, the null bytecode, was reserved for a no-op, but it was never used in the system. Okay, so I use this null bytecode as the break mechanism. So the no-op is used to break out the Arduino infinite loop and terminate fourth interpreter. Now, the fourth loop is inside this evaluate, which is a C callable routine. And let me just show you basically the evaluate. Evaluate, it actually contains a infinite loop, just like the loop in the version 5.3. So it still reads out the next byte code, and the modification is if the bytecode is a null, is a 0, then break. Okay. If it's not at 0, just keep on executing it. So this way, we can evaluate will terminate when it encounters a null byte. Okay. So here the pseudo code is get URL, decode the URL, and then call evaluate. When the evaluate is done, you assemble the nice web page and ship it out to the wherever the URL came. So I just read to you the actual loop. So you first try to ascertain that there is a client out there sending out URL. So if the client exists, then you receive characters. And the HTTP in, that's the input buffer, HTTP out, that's the output buffer. So you stuff everything, all the input characters into the HTTP in, okay? And so the HTTP in is +C, so you just stick the new characters into this buffer until there's a line feed character. When you receive the line feed character, we have to edit the URL because the URL contains lots of other information which I don't need. So, for example, %20 and get slash and HTTP slash 1.1. These are the characters which are always inside the URL. So I just delete them. There's a very nice replace function in the Wi-Fi package. Okay, so you can process these strings very nicely. So once you get rid of these characters, you put the so we need to find the length. Once you strip off the non-essential characters, we have the length of the string, and then the string is put into the C data buffer with the length. Okay, so that's the terminal input buffer. So the C system needs to know where the TIB is, and the force needs to know where the PIB is as well. So this is how the C code stuff the data into the C data common length, and that's where the TIB is. Okay, and the TIB is in the virtual force memory at the location 0, the starting point of the C data array. So you put the TIB. This is the TIB address and the length, and this is the greater in is the force interpreter pointer, which is scanning the input buffer. And once you have the TIB properly stuffed, then I have the eval, the address of eval in the virtual force memory is at 180. So if I put point P into the 180 and put the work pointer 4 bytes after P, and then I can just go to eval and evaluate that string. So this is way how you call eval, and you have to prepare the terminal input buffer, so the eval knows where to pick the characters to interpret. Yes.
How did you know? How are you able to constrain where TAB and the others are laid out in the memory space? Like you
Okay.
this in...
Yes, there are three user variables in the user variable area, and this is where I store the address of the terminal input buffer, and the prior one stores the number of characters.
Well, I see that they're in the user area.
Yes. These are user variables. Yeah, user variables, and user variables are in the area, I think, after 180. Okay, and the arrangement of the virtual force memory is that from 0, that's the C data. C data is the starting point of the virtual force memory in bytes. Okay, first the 256 bytes are the terminal input buffer, and there are 80 hex characters space, which I think I would use them for interrupts. Okay, and after 180, that's a real that's the user variable area. Okay, and the first user variable here stores the address of eval. Okay, and the fourth needs 2 pointers, P and WP. WP is always pointing to the 4 bytes after P. Okay, so you need to set up these 2 pointers to call eval. Okay. Okay, after eval is finished, so in the HTTP out buffer, all the output characters are accumulated in the output buffer, and this output buffer, all the characters need to be sent out from there. So here, let me see. So after eval finished, I need to send out a web page. So this is really the web page. Okay. Has to have a HTTP/1.1 header, and it has to signify what kind of data it is in this packet, which is this signifies text or text, but it is an HTML packet. So then I have to send out the HTML and the head and title, and put out that title, which I call ESP32 fourth 5.6. Okay, that's the header. And then the I don't understand why I have to send out that one, but you have to have that one. Otherwise, it would look for an icon file and send the icon packet. So I don't understand this. But the important thing is the HTTP out, and this will print out the entire all the characters that are being accumulated in the HTTP. Yeah. I think you reset the thing, but that's okay. Okay. So you have sent some very crazy code and it causes the system to reboot. So, and then you have to terminate the HTML with the okay, here use the pre command to configure the output as is. Okay, don't try to change, don't try to reformat it, and then send out character and terminate the body, terminate HTML, and finally you have to send another empty line to complete the packet. And then you can go and break and stop the client, and then you can are ready to for another transaction. Okay, so in here I just want to show you the if you open up the serial monitor, and when the system boots, it would indicate that it's trying to connect to the net, and it will report the IP address of the server of the. Okay, so here at home it's 192.168.1.4, but here it is 0.2. Okay. It varies. Depend upon how things are initiated. Okay, so it reports something, and then it waits for the for packets, and then it would there is an empty packet there, so you just report 000, then OK, and come back. Okay, so this is how what you would see on the serial terminal. But here, this interface is HTTP only. So the serial monitor only reports what's happening inside, but you cannot type in commands into the serial monitor because the interface is for HTTP only. And on the browser, if you give the URL, the address of URL, and then it will send an empty packet, and then you just have a OK return. If you type anything, all the 4 commands need to type after slash. Let me see. I think the next one would give you. Yes. Here, if you attach 4th word after this URL address with after a slash, then it would interpret the 4th command in there. So you can I think you can enter up to 256 bytes of code afterwards. All right. And if you type words, it will just display all the words in there. So eval is, as I said, is actually the center of forth. So it is the if you want to call from other systems, that's the entry point that you can make a forth callable through eval. Okay, and eval is also extremely useful inside forth itself. So here, for example, I have this chip has 4 megabytes of flash memory, and you can put a text file or many text files into the flash memory, and then if you implement the SPI file system, it has the regular file commands like open file, read file, write file, and all this. But in here, I only need one file. Okay, I only need one file which contains everything that the robot, the L robot needs. to initialize the robot. So I plan to have everything, all the force code stored in one load file. And when this thing boots up, it will just move that file into a location and then compile it. And this is how you instead of a terminal input buffer, you can compile any length of text anywhere in the fourth virtual memory. And so this is the load is really like just like the old load routine in Chuck Moore's block force system. But here I just want to load a text file. So you give it the address and the length. It will go there and try to compile it. And in load, in the original fourth load command, you give it a block number, and it knows where to get the text. But you only get 1024 bytes. But here, I can load in as many bytes as necessary. So here is the way, one way that eval is used to compile things other than text in the terminal input buffer. So you can just change this tick TIB and the pound TIB and the greater in. You change these three variables and you can interpret text anywhere in the fourth virtual memory that you have access to. So here for the robot project, I have basically implemented two systems, ESP 5.3 and 5.6. In the 5.3, basically it is for programming using the serial monitor, okay? Because the use in the HTTP is awkward because there I cannot, I have not found a good way to send text files. Okay, I'm sure there are ways to do it, but currently I just don't know how. So to program the robot, I still want to use the familiar serial monitor and to type in code, execute, and debug. And the only thing is that I have extended the terminal input buffer to 256 bytes. So I can really send in a very long line of code to compile. And this is what will be useful because you're typing, when you have many lines of code, you have to type in each line or cut and paste every line. That's kind of tedious. So what I did was try to combine all the word into a single line, and cut and paste that one into the terminal, into the serial terminal. This is very convenient to debug. ESP 5.6 is with the browser interface, and this is really for the final product that you want to control it remotely. And I think both programs has a boot mechanism that it will compile load file in Flash on startup. Okay, so this is the some comments about the ESP force programming. In this system, when we want to develop the robot code or code for any other application, let me see. Let me just read it. Currently, I have only a few audio commands for the robot because yesterday, Don gave me this this board for the air robot. Okay, and he said that he will be busy stuffing this board today, and he will not come to the afternoon.
Also, he has the food today, and he didn't want to give it to us, for which I'm grateful.
Okay, yeah, right. Okay, so this is the board he had already laid out, and he's going to stuff some a few of these. Probably next month we'll see a running robot or something working. Oh, by the way, my application for a booth at the Makers Fair was approved. Okay, so we'll get a booth, but the letter says they are not sure that they can give us a 10 by 20 booth. They may be able to give us a smaller one, but we don't know. Okay, but we got the booth, and from the prior experience, they will give us 5 tickets for people who want to serve in the booth. Okay, but I haven't heard anything from that. The announcement said that all the instruction will be sent out in another month. So it's good that we will have somewhere to meet in May. Okay. So I'm trying to build a full system so that we can actually program this AI robot when the hardware is available. So to program the robot or program the ESP32 board, we actually have 4 levels that we can do programming. We can change, and we can develop code. So the highest level is at the serial monitor level. So you type in 4 words, type in colon definitions, and get them compiled and get them tested and debugged. So the next level is the load text file. If you have everything debugged, you can combine all the source code into this load file. And this load file, if you flash it properly into the flash memory, and when the ESP4 boots up, it will go to that and only load that file. Okay, so you need to put everything there. I just don't want to bother with the operating system to open another file, close this file, open that. I think 1 file will be sufficient. And then you can program at the CEF level. So you the E4 system, you can edit it. And the E4 file is very similar to a regular force file. So if you have force code, you can easily include the file into the CEF file, and then it would compile the file. Building the full system, it will include all the instructions there. So that's another level. And of course, the Arduino level that you have all the C code open, and you can change things as well there. Okay, and this comment is that the Arduino serial monitor, it is very nice. And after I used to get used to it, I just threw away my hyperterminal away, and doing everything in the serial monitor. So it has a much bigger screen. It has a much larger input buffer, and you can scroll back and forth a lot. You can have a lot more information in the output buffer than the hyperterminal. And but the only problem is that it does not accept text file, while the hyperterminal accepts text file. So what I did was to enlarge the terminal input buffer to 256 bytes, so I can compile real long line. And of course, this long line you cannot type in, so you use a text file to edit and combine all the lines, and then cut and paste big lines into the terminal input buffer. And in this way, these long lines of code looks like blocks in the old for system. It's just that it's variable length. Okay, and the next level is ESP32 has 4 megabytes of flash memory. And if you load in the SPIFFS and FS libraries, it implements a simple flash file system. But I only need one file, so I can just boot and load that file on startup. So both of them can be compiled in 5.3 and 5.6. At CEF level, this is the Meta Compiler. And the Meta Compiler has a CEF Meta, CEF ASM, that's the assembly, and a CEF KERN, that's a kernel, and the force itself. So all these levels you can change. You can add new bytecode in it, and you can expand the kernel, which has basically executes only the bytecode, and the CEF file has all the high-level functions. There you have colon definitions, so you can modify the basic E4 system at this level. And when the CEF Meta system is compiled, you'll generate a ROM.h file, and this .h file will have to be moved into the Arduino system so that the Arduino compiler can include this big force dictionary in the compiled code. Yes. That's
looks like it's C.
Yes.
Okay.
Yes. Thank you very much.
Very well. Shortly after the battle of Hastings, William the Conqueror was just down the road. Yeah.
Yes. I think you show that it is possible to write everything in C. Okay.
What I'm saying is, it's not just numbers. You can actually see,
Yeah.
everything is.
Yes. It's just the problem is to compile this force dictionary into the memory. Yes. And it's very difficult. Okay. And I think it's much easier to do it the fourth way, because I'm used to that. Okay. So at this level and at the Arduino level, of course, all the bytecode has to have executable C routines to support them. But you can add new bytecode in it. Currently, I have about 70 bytecode implemented. Okay, so there are probably 180 more empty slots for you to fill. And then you can I don't know if you the fourth virtual machine, with that one line of code, I don't think you can do much about that. But if you don't like it, you can certainly rewrite your code. And the final state machine, of course, is at the how you execute the bytecode. And then the huge libraries in Arduino that you can call. Every function, every I/O, there is a library. So you just call them and don't have to worry about it. DC, DAC, to SPI, I2C, everything. Okay, you can do it in Arduino. And I think it's just that once I have fourth in C, all these routines are callable and available. So I think I would have a very hard time to implement everything individually in fourth. It would be impossible.
Yes, why reinvent the wheel?
That's right. But I think we are not standing on the shoulder of giants. We are standing on the top of an hill. Okay. Yeah. Yeah. This it's. I didn't see any giants. Okay, but I saw lots of ants. All right. ESP4 browser shows that there is a much more natural and pleasant interface for fourth to the internet universe. Okay. And with that, I think we should consider put out a fourth-like, put out a web page that would let people just experiment with fourth through the HTTP interface or the regular browser. But I think, you probably have much more experience in that. Maybe you can help. Yeah.
I was wondering, it does seem like if you change, right now you've got the situation where you're having this submit a request and then come back with a full response. You may be able to move that to be a post request, which could have an arbitrarily large set of things, and then have a terminal that just stays there.
Yeah. Okay. Yeah, I don't understand that at all. You have to enlighten me on that. Okay. Questions before we go to the demo? Any comments? Yeah.
Well, what would you need to put on the host website to make this work?
I think we just need one website instead of this four numbers. We need to have like a fourth.org, and there we can slash and type in fourth words.
So nothing needs to be put on the host server.
Actually, that's the four. You have to have a fourth. Doing the you have a server.
You have to have
a server.
You have to have fourth on the server.
Yes, yes. This server with one address, it has a fourth supporting it. So the people from anywhere, they can type in this URL and get a response. Okay. Let me just show you how how it works here, and that you can appreciate it. Okay. So here, this is the browser, and this is the terminal. Let me. Oh, well. Okay. So here, let me see. If I okay, I have this router. Okay, the name of the router is SVFIG, all capitalized, and the password is 123456778. Okay, and if you can log on to this thing, and the this is let me just reset this guy. Let me see. This is load. This is reset. Okay, you can see it locks on, and then it tried to connect the Wi-Fi, and it succeeded because I have the SVFIG and 1, 2, 3, 4, 5, 6, 7 all entered into the code. So the server knows has the address and the password, and it reports IP address. That's 192.168.1.2. And if you can log in this router, and then this is the URL that you need to type in for communication. Okay, so here let me just show you. If I just take out all the words and hey, wake up. Why it is still try to it's still try to connect. Okay. Let me just reset it. Okay. So this guy is doing fine. Let me see what I am. My connection. Well, I'm connected, so I should be able to just maybe it's because this guy is too old. Okay, let me bring up a new page, and okay, let me try this guy. Probably it was because I have 4 instead of 2. Okay, give it a 2. Yes. Okay. So it connects. At home it was 1.4, and here you just typing words, and it reports back the and you can type in any words after the slash. Okay.
Oh, what if you have more than one word?
Oh, they just keep on typing.
If you go 1 space 2.
Yeah,
space
yeah.
Plus space.
Yeah, sure.
Yeah,
Let's just do that. Okay. 1, 2, 3, 4 plus. How's that? Okay. 1, 2, 3, 4. It's 3 and 4 plus. You got 7, right? Yeah. Yeah. So this is just like a hyperterminal or things. It's just that the URL is not just a symbol field that you can type in. But I think we can in the browser we can open up input field to accept the.
We can make this better.
Yeah, definitely. Yeah.
Nowadays.
Yeah. So I think I think the web page that we sent back here, I didn't send anything. I accept the text. Okay, but we can always put in buttons and different fields to accept whatever the communication we desire. But I think at least I demonstrated that from a URL, you can use it as a fourth terminal and sending lots of stuff there. Okay.
Okay.
Any more questions? Yeah.
But one comment more than
Yes.
a question is, I see you still got Arduino in there. Arduino's huge. It's a monster. With the ESP32.
Yes.
The company that makes it is Express.
Yes.
They have a what they call an IDF.
Yes.
Which is a pure C environment.
That I.
Much nicer.
No, I just couldn't make use of it.
Okay.
Yes. I think I need an expert if you need to go that route.
Because I got tired of the overhead. I'm going for very, very exceedingly low power.
Yeah. Right.
I had to get rid of Arduino.
Yeah.
Arduino is just too big.
Yeah. But you know, it's the without having to think about the C and everything.
Correct.
Yeah. Let me just show you what's underneath it. Okay. Now I have done the demo. I can feel free to change things. Okay. So here, this is the Arduino. Okay. Show you the compilation. The compilation of the system. Okay. Okay. Let's do start the download, and you can see. You can see what's happening underneath.
And there is sort of the trade-off is the Express IDF takes a lot longer to compile because it's compiling everything.
Yeah. Right.
And so this is where Arduino shines.
Yeah. And I think it's the it's for the common people. Okay.
Yeah. Yes. The other one takes a little bit more work. I agree.
So it's compiling, and especially it's finding that it needs the Wi-Fi library.
Yeah.
And it needs the SVFIG file system. The file system, there's 2 libraries you need to load, and there's a whole bunch of things that has to be called out. Okay, here is the SPI, FFS, and FS. These are the file system, the flash file system. And then now it's doing the compiling. It just recognize all the library it has to load. Now it's loading up all the library, and you can see this this thing goes way out onto the street. Okay, so it's a very long lines of commands. But as I showed you last time, you can just cut out these lines and then compile them as a bat file. Okay, so I was very happy to at least I can make use of some of these things, and I can look up the files, look up the C code and the .h headers. And let's just wait until it finishes compile. I'll show you how much code that it generates. And okay, there you are. Okay.
How big is that?
So you need to press the load button in order for it to start loading into the flash memory. Okay.
108,000 bytes.
No. It's a 700,000. Okay, it started. It stopped. So let me see where is the number.
Is it this one? 7?
Yes. This is almost 0.7 megabytes.
That's not very important. But you have all these libraries that you're hopefully going to use, right?
No, no, it's not hopefully. It's the yeah.
Oh, okay. So
Yeah.
you will get
It's pour in pour in whatever the command it needs.
That's fine.
Yeah.
But the libraries are big.
Oh, yes.
It's Arduino.
Yeah.
Yeah.
So you know, as
Well, they're not as good as you would think it. There's still
Yeah.
things that aren't needed.
Yeah.
One little static dependency and you get all
yeah,
Double
Yeah.
the size of your object.
yeah, I think it's just now that we are. I'm doing all these things before the robot code came in. Okay. Yeah. I don't know if it will blow up the memory when Don's robot is ready. But then we'll figure out.
That 4 megs to work with. Right? So,
4 megs, it's gonna be a while. Well, not too long.
Okay.
It's fairly good size.
Okay. Thank you very much. I think it's time for lunch.
We have a public service
Yes.
Because of the nonsense that's going on the first floor, if you want to use the bathroom, use the one on the second floor.
Oh, second floor. There is a.
It's
Oh,
open.
I see. Mhm.
Yeah, you just go out the door and turn left.
Turn left. Okay. All right.
Save room for pie, because celebration of Pie Day at the break this afternoon.